Okay, so I want to start with these three identities. These are more questions from the test one reviews that students have sent me emails about. This first question, this first identity, we're looking at this and we're going to use the double angle identity for cosine. This is because on this side, we just have sine squared and we just have an x. So getting rid of the 2x will help us here. So cosine squared x minus, and then the double angle identity for cosine is cosine squared x minus sine squared x. And then distributing that negative gives us what we want, and that these two cosine squareds cancel, and we're left with sine squared x, which is what we wanted. Number two is a little bit harder. I'm going to work on both sides on this one. -2 times, then writing this as sine t over cosine t, and then secant as 1 over cosine t. So we have -2 sine t over cosine squared t. Multiply straight across when you multiply fractions. Then I'm going to work on this side, and I'm looking at this and I see I need a common denominator, which is going to be the product of those two denominators. So I have sine t minus 1 times sine t plus 1 as my common denominator. Now, this side is missing the sine t plus 1, so I'm going to multiply top and bottom by sine t plus 1. That gives me a 1 times sine t plus 1 here, but the 1 times I don't really need. On this side, I need to multiply by sine t minus 1. So then I have just that again, because of the 1 times, you don't really need the parentheses there. Luckily for me, these cancel, and I have 2 sine t on the top, which is really good because of where I'm trying to go. On the bottom, I actually have sine squared t minus 1. I am going to show you how I got that, but it is foiling. So take this over here, say. We have sine t minus 1 times sine t plus 1. We're going to do first outer, inner, and then last. So these guys cancel and we're left with sine squared t minus 1. Now, I want to use the Pythagorean identity to get from here to here, but I can't quite do that. But if I take a negative out of this and write that as just multiply negative through basically, or pull the negative out so you haven't changed the value of what's going on, that would make this a negative sine squared t and then plus 1. And then on the top, we have 2 sine t. So on the bottom, you're looking at 1 minus sine squared t, which is cosine squared. That's Pythagorean identity. And then you are done. Seeing that this is the opposite of what you want is the trickiest part of this one. I mean, once you get past the common denominator stage, but the sine squared t minus 1, that's really close to the Pythagorean identity, and that's what you need. Just basically pull a negative out. You're factoring a negative out, so you haven't changed the value of anything, but that's going to change both of these signs. And then you have 1 minus sine squared t, which is equal to cosine squared t. Okay, and then lastly, if we work on this one here, this is actually from your notes. 1 minus cosine squared x on the top, again, Pythagorean identity. And then 1 plus cosine x on the bottom. On the top, I'm going to factor that as the difference of perfect squares. Oh. And then that allows me to cancel. And so I'm going to get rid of this and this. And then we have 1 minus cosine x. So I have 1 minus 1 plus cosine x. That makes these go away, and I have cosine x left. Okay, and then another question that someone asked about was number 7. So number 7 is, this is just your just regular trig identities, the fact that the cotangent is cosine over sine. So on this one, is 1 over tangent. These just cancel and you get 1. Because cotangent is defined to be 1 over tangent, so they cancel each other out. This is the Pythagorean identity here, sine squared theta plus cosine squared theta. It doesn't matter what theta is, it's 1. In this case, theta is pi over 5, but we don't really care. Okay, and then lastly was another example with the double angle identities. So I'm going to do this one, number 2 on the shorter review, the time one. So we have sine of theta is 2/3 and theta is in quadrant 2. So we are going to just sketch this. So sine is 2/3. Then we're going to figure out what the x value is. So x squared plus 2 squared equals 3 squared. So x squared plus 4 is 9. So x squared is 5. So x is plus or minus root 5. So this is going to be negative root 5 because it is to the left in the xy plane. So cosine of theta is going to be adjacent over hypotenuse, so negative root 5 over 3. Tangent of theta is opposite over adjacent, so 2 over negative root 5. Cosine of 2 theta, we're going to use our identity, the double angle identity, so cosine squared theta minus sine squared theta. And then plug in what you know. Cosine is negative root 5 over 3. We're going to square that. And sine is 2/3. That was given to us. We're going to square that. So this is 5 over 9 minus 4 over 9, which is 1/9. Okay, and then the sine of theta plus pi over 2. What we want to do here is, again, use an identity. This is going to be the sum formula for sine. So it's going to go sine, cosine, cosine, sine. Same sign in the middle. So theta pi over 2, theta pi over 2. So some of this is going to come from our picture, and some of it will come from the unit circle. So the sine of theta in our picture is 2/3. The cosine of pi over 2 on the unit circle, the cosine value here is 0. The cosine of theta in our picture is negative root 5 over 3. The sine of pi over 2 on the unit circle is 1. So this answer is negative root 5 over 3. Okay. So that covers some of the double angle stuff inside of identities, some of it inside of a triangle problem. Hopefully that answers all of your questions.